All right, I think we can give it a go. So, good afternoon, everyone. My name is Sebastian Ng, and today we'll talk a bit about the Fronius Gen24, really having the focus in terms of the future proofing of the product, and we'll talk a bit about some specifics about the inverter and what makes it pretty unique here. I can see that there's still some people joining the session, but we'll take it from here. So, all right, so let's have a look on the Gen24. As most of you have heard, this is our new generation inverter. So we call it the Gen24. And of course, there's the single phase and the three phase version. Before I go in and talk about all the technical details of the inverter itself, I think it's always good to do a bit of recap. So before, when we're discussing, okay, what has been covered before, I think one of the few slides may become a bit more familiar. So one of the things which is very special with this Gen24 is how we make them, right? And when it comes to making the inverter, we always look at the sustainability side of things. So some of you who has heard about from the start how Fronius started with the business, it was with battery being thrown away. So we wanted to have like a technology so that you don't need to throw those batteries, those car batteries, and having a charger, for example, to be able to recharge those batteries, right? Those car batteries. And sustainability has always been the core, let's say, at the core of the Fronius business. And that's why also when it comes to building new product, we had to rethink a bit how we do it. And if you look at the Gen24, we have a whole product lifecycle analysis, which is available on our website and which of course we can share with you. But we had to look at every single part, not only how we make the inverter, what components we have with the inverter, but we also had to look at the transportation of the inverter. And also the end of life of the inverter. What happened when we need to dispose it, right? Or can you reuse the product? Well, why this is important? If you look at the current situation with different shortages, if you create a healthy environment, or let's say a healthy cycle in terms of products, that's where you can make those inverters from, let's say, recycle components, and then from there, at the end of the life of the final product, you can again recycle and use it again and again and again. So you create this whole ecosystem where it's pretty independent from having, let's say, the new parts, trying to make it more efficient and sustainable. And when we look at the life cycle of the Gen24, when we look at the start, right, what we wanted to do is in terms of manufacturing the inverter, in terms of production and manufacturing, we use 81% of renewable energy. Of course, the percentage is a bit higher because we use power also from the grid, right? And we use green energy, but from our own solar system, 81% comes from renewable energy. So this is everything about heating, cooling system, everything to make the product itself. Then recycling also is a big part. I think a lot of members joining us today knows about how, in terms of servicing our product and how our whole exchange process works, right? We don't want the inverters to end in a landfill. So we want to make sure we can recycle the parts, we can bring everything and reuse it as an example. So if you look at our packaging, 90% can be recycled. Also the heat sink, we use recycled aluminum to make them. And we try to make sure that on the long term, as an example, if we need to bring back the unit in Melbourne, that we can reuse it as an example. Then when it comes to transportation, of course, all our inverters are made in Austria, the one in Europe. And we need to transfer all the transport all the product to Australia. Of course, if we need to air freight all those products, we will emit a lot of CO2 emission. But not only this, if you look at the COVID situation, everything that is air freighted costs way more money, right? So that's why we try to in terms of transportation, in Europe, we try to use a land or trains, land transport, so train or truck. And when it comes to the product coming to Australia, we try to use a sea transport as much as we can. And by doing so, we were able to reduce our CO2 emission by 27%. The last part is the durability of the inverter. So one thing which I think we are very well known is about the quality of the product. And we also touch base about the reliability before during our training. When it is important, when we produce and make our inverter, why does the customer pay more? It's because of the durability. It's because of the quality. And here, of course, we're here to talk about the Gen24, but let's look at his, I would say, bigger brother, the Snap inverter range, which has been installed since 2013 in Australia. Since 2013, we're nearly hitting the 10-year mark, and the reliability of the product has been pretty good with all the feedback that we are hearing from the market and also from the data that we have on site. So as you see, this is also a very important part. And what I would highly encourage is when people are saying, okay, what's the proof behind the life cycle of the inverters? So we actually got a third-party institute to actually come and investigate all the processes that we have, and also confirming that it is one of the most, I would say, sustainable inverter in the world, right? So we need to make sure we have all the information, but also check from third party that it is a case. So all of this in terms of procedures, putting the inverter together, all of this fault, all the R&D that goes into place there, all this work behind the scene that sometimes we don't see, was very important to achieve this inverter, which I would say is one of the most highly anticipated product in the market. Of course, when we design this inverter, we always think about the future need. What will the people will need in terms of features, in terms of needs? So, of course, one of the big topic is or are batteries, right? So everyone wants to have batteries. So we want to make sure that the product is future-proof, that you can have more than one options when it comes to adding a battery there, right? So let's have a quick look into the inverter itself with the Gen24. So there will be a few important parts to remember at the start, because we'll cover that also at the end of the presentation. So the first thing is, I mentioned that Gen24 is a new generation of inverter. What we did is to make it simple for everyone, even for us. We kept the name Primo or Symo. So Symo means symmetrical output, which means three-phase symmetrical output. So the Symo will be the three-phase inverters. So when it comes to the Symo, there are two, let's say, group. There's the one which are the bigger ones, so the 6 to 10 kilowatt Gen24 plus, and then there are the smaller one, which I will cover just after that. So let's go through the 6 to 10 kilowatt first. So again, three-phase inverter. The power class will be 6, 8, and 10, so 2 kilowatt increment. Those inverters has 2 MPPTs, so this is for the panels. And what you can see here is we have a very high amperage on the first tracker, and then a lower amperage on the second tracker. So what does this allow you to do is paralleling on the first tracker, for example, because it has a high ampering here, and then bring one string to the second one as an example. Also, with the starting voltage of the Gen24, a minimum of 3 panels is enough. Also, we have a 1 battery input, which is at 22 amps. And with this battery input, you will see why it has a benefit to have a high current input like this. Also, this Symo Gen24 has a larger housing compared to the Primo or the smaller Symo. And you can do a three-phase full backup or PV point. So you need to remember we have 2 options when it comes to the Gen24 Symo 6 to 10. You have 2 options, and I will explain what's the difference between the full backup and the PV point. The smaller one, so the Fronius Symo GEN24 3 to 5, so the power classes will be 3, 4, and 5. And the MPPT is a bit different from the bigger one. So it will be 12.5 on each. Again, minimum 3 panels. The battery input is a bit lower, but this one has only PV point, right? So that's very important. And it has a small housing. So from our perspective, from the feedback that we got from the market, usually when you have 3-phase, you will usually have a bigger system. That's why you usually go 3-phase. And if people ask, I usually say 6 to 10 kilowatt is usually the way to go, except if there's any other requirement. But that's our go-to. But if some customers needs this option, it will be available also in Australia. Looking at the most common type of connection in Australia, which is single phase. So this is the Primo GEN24, so Primo, which is a single phase, and it will come in power classes of 3, 4, 5, and 6. And it also has 2 MPPT. So same thing, 22 amps. So we put a lot of amperage on the first tracker, and then the second tracker is kind of like a secondary tracker. And also only 3 panels is enough for a string, as an example here. It also has a high battery input current, so 22 amps. You have also the full backup and the PV point available on this inverter. So you have 2 backup options. And this one also has the small housing. Right. Whoever comes to the session to Sydney also next week, where there is the Smart Energy Conference, there will also be all those units in display, where you will be able to touch and feel it like real units, and also looking at the actual dimension there. So talking about the trackers, as you can see, the first tracker has usually higher input current compared to the second one. The reason that we have it this way is to give you more options when it comes to paralleling on the first tracker and then bringing a second string to the inverter. So when it comes to string configuration, you can see that in some situation, if you have, let's say, east-west, or different orientation. So you do 2, let's say, long strings of the same amount of panels parallel to one tracker, and then bring, let's say, a smaller string to the second tracker. Or you can do a split. So you put 50% of your string on the first tracker and 50% on the second tracker. So it really gives you a range in terms of design and gives you a lot of flexibility where you can put your panels. And for example, you can do like northeast, northwest, so different, or west, east-west as an example. So in terms of the capability and design, you can go on the Fronius Solar configurator, which will allows you to have all the options and possible configuration. So definitely I encourage you guys to have a quick look. So in some cases, people think that, oh, I can't fit panels here, or 3 panels is too low, but it is enough for this particular product. So always have a look on the solar configurator. The next thing, which is a bit special with the Gen24, is also the design. I'm pretty sure a lot of you guys have seen the heatsink, and also from previous presentation that we mentioned about reliability, about optimization, how active cooling is important. You can see that for Fronius, we haven't moved away from fans because we know that fans are very important, but I will cover that a bit later on. But when it comes to the heatsink itself, I actually really like the design. I sometimes prefer the inverter without the cover from personal preference, but you can see those small things. And having this new design, we invested a lot of time and effort, and also with the fan being a bit bigger than the previous fans that we have on our Snap, we can also suck all the air in from the front and blow it through the heatsink. And with this new design, what happened is we have a more efficient cooling system, which reduces hotspots. So if you can see an example of a heat map, that we can keep the inverter very cool. So I have like few customers even saying that it's really hard sometimes to get the inverter, to get the fan starting, because the heatsink actually is doing a lot of the job there. So why do we have active cooling? So we know that it increases the lifespan of the inverter, but also it helps in terms of harvesting energy. So if you look at this picture, you can see that if you compare an active cooling system to a passive cooling system, we can harvest more energy, because when it's, let's say, in the middle of the day when it's very warm, and you can actually get more power, right? The inverter actually derates if it is a passive cooling system, because you can't in terms of performance and in terms of chips, say components management, the passive cooling system needs to derate, or else the lifespan of the components will decrease. So that's one of the benefits of having an active cooling system. Not only that, if you look at how much we can harvest from those trackers, you saw before the Primo, I think, has 22 amps, and the Symo has 25 amps. To be able to harvest everything and push all the power, having an active cooling system there really helps to be able to do this job, as an example, to harvest all this current. So then the next part is the batteries, right? Because batteries are becoming also one of the most common topic out there. And with the Gen24, the battery which is compatible is BYD. And just to explain a bit what BYD means, it's basically build your dream. So for the people who doesn't know about BYD. So BYD is a big Chinese company. They provide batteries for different sector, automotive sector. They do like big solution. I think some people in Queensland with the bus, I think at the airport, they are basically BYD buses. So they provide a lot of solution. And also I heard that their cars also are coming out to Australia. So they are very huge company in terms of battery solution. So the batteries that the Gen24 is compatible is the HVS and HVM, so the premium version. And the S and the M basically stands for small and medium. Depending on what you have, you will have different, let's say, capabilities. So let's have a quick look through it. Of course, the BYD battery are lithium iron phosphate, so one of the safest battery chemical that you can get on the market. One good thing with BYD is that they are modular, so you can start with 2 modules, then from there the customer saying, look, I need a bit more, you can add, you can come back and sell, let's say, add 2 more modules or add another stack next to the BYD battery. So depending on which options you go, so the HVS, they are small, so you can go up to 10.24 kilowatt hour. Compared to the HVM, you can nearly double it, so you can go to 22 kilowatt hour. So both are the same retrofittable step, so it's 2.8 kilowatt hour. It's pretty straightforward, ground mount and easy commissioning process there. I'm pretty sure some installers here with us will have some stories to tell and some experience to share with us here. So this is about the options. Now, what we did is we created a cheat sheet to give you different options, because that's going to be important down the track to get the customer to understand what they are buying. So here you will see the charge and discharge of the battery, depending on which inverter you have and also which battery you have. So just to give you an example, a Symo Gen24 Plus 10 kilowatt hour, 10 kilowatt, if you connect in HVS 7.7, you get 6.7 charge or discharge. If you go bigger battery, so HVS 10.2, it will be 9 kilowatt charge or discharge. Now, if you go in HVM 11 kilowatt hour, right? So the in terms of storage capacity, it's nearly the same. The charge and discharge is around 4.49. So you're saying, okay, how does this make a difference, right? Why is this important? If you have a customer where they get a quote with a Symo Gen24 10 kilowatt and you have a HVS 10.2 kilowatt hour battery, the charge and discharge will be 9. But if a competitor comes in and offers an HVM, maybe the price is lower, with a Symo 10 kilowatt, the charge and discharge will be 4.49. So it's very important to explain to the customer what they are buying there. Just to give you an example, if this inverter goes in backup mode, as an example, the Symo GEN24 plus 10 kilowatt with an HVS, then you can provide 9 kilowatt. But if it is a HVM, it's only 4.49. So that's where it's important to explain to the customer what's the difference between the batteries that they are going for. So this is just a cheat sheet just to understand which one, depending on which combination you have, what is the charge and discharge that the customer will get. Of course, some customers will want more than one stack. So here we have a second cheat sheet which tells you what you can do and what you can't do. So for example, you can have a Symo GEN24 10 kilowatt inverter with two of the HVM 22.1, which is total of 44.2 kilowatt hour. If you want, you can do 3 HVM of 19.3, which I think is 57 kilowatt hour. Again, you can do multiple of those, like different combination here. You can do 2 HVM or 3 HVM 13.8. The only thing to remember, the charge and discharge will stay with whatever size it is. So just to give you an example, if you decide to go with a Symo GEN24 plus 10 kilowatt, and then you say, okay, I want 3 of the HVM 19.3. Your charge and discharge won't be 9. Your charge and discharge will be 7.88 there, which is a small difference from here to here. If you do 2 HVM 22.1, then it's 9 kilowatt charge and discharge. So whichever one you select here, the charge and discharge will stay the same, even if you have 2, even if you have 3. So that's something which is important to have a chat with the customer of what they actually needs there. But 3 batteries is quite a lot. I've seen one of the customers who actually bought 2 GEN24 with, I think, 1 battery each. Within a week, they were already saying they want another battery added to each inverter, which is a lot of storage there, just to give you an example. Also, if you want to have multiple GEN24 with batteries on site, it is possible. That's where you will need to install a switched-in device, which will do the controls of basically doing all the smart controls there. Things can get a bit more complicated if, for example, you want to do backup. So as soon as you have 2 GEN24 and both of them has batteries, please get in touch with the application engineers. We will have a look at your criteria and give you some recommendation. But it is possible to have 2 GEN24 with basically batteries on each of them. And if you need to do backup of both, we can have a chat about it. It's a bit of a different setup, so I highly recommend, if ever you have this type of situation, to just get in touch with the application engineers. We already have customers who's done it. So we have 2 GEN24s, a battery on each, and then they want to do, for example, backup on each. It just gets a bit trickier, and we need to explain more in details how this is achievable. But it is a possibility with multiple GEN24s. Also, with the unit itself, we have the multi-flow technology built in it. And what is the multi-flow technology is we can do 2 things at the same time. So we can charge the battery, so send power to the battery and send power to the load or to the grid at the same time. Also, we can do the same if, for example, there is a blackout, we can charge the battery and send power to the load at the same time. So that's, for example, if you compare that to an AC coupled solution where we can do only one thing, which is charging the battery or discharging the battery. So this is one of the added benefits using the technology. Also with the Fronius GEN24, if you have another Fronius on site, so you can also charge from the PV directly to the battery and also from the other inverter to the battery. Or you can discharge power from the battery, of course, and take power from the panels at the same time and send it to your load or the grid if needed. So if you look at the whole solution, it can be this third-party inverter, it can be a Fronius, it can be a non-Fronius inverter, but we can take power from the AC side also. The other good thing with the GEN24, if you want to use it as an AC coupled solution and you don't have panel connected to it, it is possible. So you can just retrofit a GEN24 and a battery on the side if you want. That's also possible there. All right, so why do we go with DC couple? So in terms of DC coupling, it's usually more efficient because you don't need to convert, for example, DC to AC, then AC to DC again. You just go directly DC to DC. So this is one of the system performance index that we have that we basically participated in with where it comes to 5 kilowatt system, the Fronius was coming first. So it's a combination of the Gen24 and the BYD battery. Remember how we had this high current input? That's how we were able to also have this high percentage of 92.2%. We can charge the battery pretty fast and discharge the battery pretty fast, but also it's a DC couple solution. So we just send the power directly to the battery instead of doing 2-stage or 3-stage power conversion. Also for the 3-phase, so this is the inspection for 10 kilowatt system. That's where we were second there, not too far from the first one. So it was a 10 kilowatt Symo Gen24 with a BYD again, so 22 amp of charge current and discharge current. That's how we were able to do it. So one of the reasons why to go DC coupling is also the efficiency. So you don't need to convert energy multiple times. Remember, every time you do a conversion from DC to AC or AC to DC, you have an efficiency loss there, which you need to take into consideration. So that's also one of the reasons why to go DC couple. So now jumping to the other unique, versatile option with the Gen24, which is basically the backup option. So remember at the start, I said there is 2 different backup options. So with the Gen24, there is something which is pretty special when it comes to backup, which the first one is a PV point. And this is already inbuilt inside the inverter. So I will show you a picture of what I mean there. So with the PV point, some of the important things to remember. So this PV point, right, it has power only when the grid is off. It's basically will have an automatic reconnection. The maximum of power that it can deliver is 3 kilowatt single phase, and you don't need any other extra component, not as many as doing a full backup. So how does this work? With the Gen24, you have your AC connection, which connects to the grid or connects to your switchboard. Inside the inverter, there's a secondary AC output, which you can wire to a GPU. From there, when the grid goes down, you can get power from the panel to PV point. You can send power to the battery because it has multi-flow technology, so we can do those two at the same time. Also, if you have a battery, you can take power and send it to the PV point. The other beauty of this is you don't need a battery for PV point also to work. So you can have a Gen24, you can have PV point. If the grid goes down and you don't have a battery, the PV generator, the panels can supply power to this PV point. From there, if, for example, you don't have enough sunlight on the PV, for example, and you're trying to draw more than whatever is available, the inverter will shut down, right? And it will do it, I think, 3 to 5 times, and then it will just shut down until you come on the screen and press on it. So this is also an option to have backup without a battery. And remember that the PV point, you need to come and manually plug into this PV point. So it's not an automatic, you need to come and manually coming and plugging into this GPU. The other option, which is doing a full backup. So usually, if you look at the Gen24 10 kilowatt Symo or 6 to 10 kilowatt Symo, usually, depending on the house, most of the time you can supply the entire household. Again, it depends on the house or how much energy they use. So you can do single phase or 3-phase devices. There's around an automatic switchover of around 60 to 90 seconds. And from there, if you look at the maximum energy consumption, which is basically you can do the multi-flow option. So let's have a quick look of what this means. So when you do a full backup, now you will include a backup switch in the whole loop, right? As soon as the grid goes down, the backup switch opens up, and then from there you can send power to the battery or send power to your loads, and this is automatic. And of course, you can take power from the battery to the load, to the essential loads also. So that's what we have with the multi-flow technology. This backup switch, there is a sales partner who actually have everything pre-wired. I think Bewa has a box already pre-made if you want to have a look, but we also have document of how to do your own box. So it's really up to you if you want to make it yourself or if you want to just buy it like a pre-made box. And of course, you can do three-phase backup as mentioned, like proper three-phase devices. So remember that the Symo 3 to 5, the Symo 3 to 5 can't do this option. It can only do PV point. As mentioned before, looking at Australia, most people will go for the bigger Symos. That's where it's usually used, the 10s, the 8s, and that's what we see. And we think that usually the smaller Symo won't be too common in Australia. But those are the options in terms of backup. So what I showed you up until now is for, let's say, new system most of the time, right? I'm pretty sure some of you guys have already customers who has, let's say, Fronius inverters on their wall. So with those customers who has Fronius inverters on the wall, all those existing system, what I would mention is it's important to have a Fronius smart meter, right? Or if you have some customers who are not ready for the battery, but they are going for a Gen24, this one, no need to think about it, put a Fronius smart meter. Why putting a Fronius smart meter? Because if you put a Fronius smart meter and you put the system online, you will start to have data. And for some of you who came to our training, having data is very important. It gives you visualization, not only, for example, for our tech support, if something happens, just to be able to debug, but also in the future, when someone wants a battery, you can do simulation. So for all of you here who came to our training before, and also looking at all your system in the past with Snap inverters, which has a smart meter and it is online, what you can do is log in on your profile, go to those particular system and do a battery simulation. How do you do a battery simulation? This is how it should look like. If you have a Fronius smart meter, click on analysis. Then from there, you will have all those options. So ignore the internal, this is just for us. But you will have a simulation button, click on this. And then from there, the first option will be to run a simulation if you want a Ohmpilot or heating, if you have a heating element and you want to use a power diverter. But you can click on storage. And when you click on storage, those are basically the battery simulation. And this is based on the data that you have already recorded. And usually I use like 3 months of data. It's pretty good. From there, you will just change the different size of battery. So you can select whatever size you want. And also you can say, okay, if I want to have backup capacity reserved in a way. So if you have some cases where if there is like a grid outage, you want to make sure you have 20% of the battery. So you can put like 20% and then it will run some simulation. And what is interesting, which I always share, is I've done this few times with a few different installers. And what is very interesting is some people say, hey, I want a very big battery. So we did one experiment with one customer where we changed different size of battery, and the self-sufficiency, which is basically how independent you are from the grid, didn't really change. The reason for that is the customer didn't have enough excess of power. So going for a 10 kilowatt hour battery or going for 22 kilowatt hour battery, this percentage was the same. So what we recommended is let's go with a smaller battery. Then from there, add also more panels to the system, because from there you will have more excess of energy where you can charge the battery. So that can be also a big difference, because if everyone is going and telling the customer, hey, you need to have this size of battery, this size of battery, and you go and do the simulation, you say, look, it doesn't really make sense. You won't have enough excess of power to charge this battery. So why are you going for the battery? Let's add more panels first as a first step, and then we assess, right? So you can see in terms of providing this solution, providing this service to the customer, it's a bit different now. It's a bit of a different conversation that you have with the customer. So those are the steps which are available to you and to the business. Of course, we mentioned the battery storage today. So we spoke a lot about battery storage, different options, different configuration. The customer usually will, this is the first thing that they want. But as soon as you show them the price, they're like, oh, okay, maybe not a battery right now. Usually, if you look at the story with solar over flow in terms of going through the battery journey, usually customers will try to make the most of what they have installed, which means trying to use their energy, their excess of energy. And the easier way to do this is usually to store energy in terms of hot water, as an example. So that's why we have our Fronius Ohmpilot as an example, which is a stepless PV surplus energy device. So what we do is, as soon as you have excess of energy, divert it to your hot water system. Then you also have another option where, if you look at Australia, the EV market is, I would say, booming here. Still a bit behind compared to other countries, but we are getting there. That's where the Fronius Wattpilot will also make sense. So let's have a quick look in terms of the whole journey, in terms of looking at the overall solution. So the first thing is you have the Fronius inverter. Having a Fronius smart meter is crucial, because that's what tells you how you're using your power, right? Are you using it directly from the PV generator, or using power from the grid? When are you using the power? From there, of course, we know that we can control loads. We can control up to 4 different loads. So if you have excess of energy, turn them on or off. And then from there, you can install multiple smart meters just to monitor specific loads if you want in the house, right? So this is energy profiling. From there, you can decide, okay, we have excess of power, we are not ready for a battery. Let's look at, for example, the Fronius Wattpilot. So here, this is not the final version, because there's a version 3 and 4 coming to Australia. So this is what is sold at the moment in Europe. So we will have in the second half of the year the Fronius Wattpilot in Australia, which is basically an EV charger. There will be 2 options. So there will be a Wattpilot Go, which is one where you can carry along, bring with you. And then you will have one which basically is stationary, as you usually see. There will be 2 different power classes, 11 and 22 kilowatt option. In terms of the Wattpilot itself, there will be a special training on the product itself, because there's also an app where you can do different controls. So you can set like when you want to charge, when you want to discharge. There's like a special app with this. We're also looking at visualization on Solar.web, where you have everything already there with your PV, with everything. So there will be more information. But as you know, with the solar journey, that will be maybe the first step, is to divert this extra energy to maybe your electric vehicle. Of course, not everyone has an electric vehicle. That's why the Fronius Ohmpilot also can be a solution. So it diverts excess of energy. So we can do up to 0 to 9 kilowatt. Usually it's resistive load. So like your heating rod, sometimes heat pump. So that's where you can increase your self-consumption rate. And we all know that there's this energy management, which I mentioned at the start. You just need to use external contactor to turn on and off different devices. There's quite a few out there where they say, okay, when I have extra energy, turn on this contactor, which is also a cost-efficient option there. But it's all about diverting this extra energy there. Also, there's a lot of open interfaces. That's something which is also very interesting. just to give you an example, we also have Alexa available with our Solar.web. You just need to get the premium version and you can say, hey, Alexa, how much energy my system is doing. But having those open interfaces is very important because it allows us to talk to different devices and give a lot of let's say opportunity and options to the customer. So as you know, there's a lot of houses getting smarter and smarter. There's like smart appliances. So you want to make sure that your inverter also can integrate with those different options. So for example, we have our Modbus TCP, which can TCP and Suspec alliance that we have, where we can talk to different BMSs, building management system, for example. It's also available on other Fronius inverters. We have digital AUS, so there's a lot of options to the customer. Of course, Wi-Fi and LAN connection to the inverter, I would say is kind of standard now, like every product should have options like this. But we want to make sure that it's not only one thing or one product or every time it's Fronius. The customer has control of, okay, I want to talk to a different home automation, not like a Fronius branded one. So we wanted to give the customer a lot of flexibility there. Of course, if you want to do something a bit more in depth, so there are like some customers who does communication with like a Loxon device, which is kind of like a PLC controller, a smart PLC controller for home automation. So we give a lot of options again to the customer there. The last part is the service. So pretty sure you guys know our service process that we explained before. We have our tech support here. In Australia, we have a service team. Sometimes we don't talk a lot about our service team in the office. The team basically arrange the product to be sent out. Those are the guys who gets the product back in here. We have a repair center downstairs where we do all the testing, making sure that the inverter works. Basically, we repair the inverter locally here, and then it goes to our exchange pool. So we make sure that the whole process is smooth. And that has always been our vision in terms of servicing, because if people depend on the solar more, you want to make sure it is reliable, of course. But if something happens, that you have is a procedure to make sure that the system is running back as fast as possible. Same thing with, I take an example with your car. If you have a flat tire, you want to make sure you have a spare tire. So it's the same process with the GEN24. We wanted to make sure that it is basically very quick and efficient. So we usually say that it is the fastest service on the market. There's only one big power stack with the inverter, and then one pilot card, which is our new monitoring card. So those are the two parts which usually get exchanged, but it's pretty straightforward. Most of the time doing an update, trying to fix it, but what we're aiming is one site visit and the problem is solved. So that's how we want to make sure that we go in and we fix it as fast as possible if something happens. So that's pretty much it for today. We'll take maybe a few questions after going through a quick summary. Someone was mentioning, let's go through a bit of a summary of what has been discussed throughout the whole webinar series that we have. So the first one, of course, we discuss about the history of the company, where it all started with Mr. Gunther Fronius, 75 years. I think it's a bit more than 75 years if I do my calculation. I think it's 77 years now in power conversion. Then we shifted to looking at optimization, so design optimization, making the most of what you have, which we also covered a bit today. Also, we look at design using our Solar Creator, which will be the new tool which will replace the Solar Configurator that we have at the moment. Different design configuration, where to put the inverter, east-west shading also was covered before, which is basically this, the next point shading that the string inverter can also deal with differentiating condition, that you don't lose the whole string if one panel is shaded. We spoke about reliability, different testing that Fronius does, and also sustainability. This is one of, I would say, the biggest point for us, because we can already see that coming. The way that we look at it is the same with batteries at the start with Mr. Gunther Fronius, because people were throwing batteries, and we can see that also happening with panels. What are we going to do with all those panels ending in landfill? So that's where on the inverter side, we want to make sure that we learn from, let's say, previous mistake, and making sure that in the future it's more sustainable and we don't need to do things twice, as an example. And of course, today we discussed the GEN24, the new product coming in Australia. That's where also we have some news next week. So whoever is joining us at Smart Energy next week in Sydney, please come by and say hi. The whole team will, not the whole team, most of the team from Melbourne will be there. Come and say hi. We'd love to meet some of you in person. So definitely it will be very good from our side. So let's see who has the first questions, because I've seen that some people were typing throughout the session. So let's see who has also, okay, this few question. All right, so the first question is, what's the wattage on the GEN24, and could we connect a battery to that inverter? So the GEN24, yes, you can connect a battery to it, and depending on which GEN24, I think this was an early question, which I covered a bit after that, but that's fine. So the GEN24, there is different wattage. So you have the single phase, which goes from, I would say in Australia, will bring more 4 to 6. And for the 3 phase, it's 3 to 10. Okay, there's another question. So we are starting to see panels with a IMP of 13 amps. How will you guys be handling this transition in the market? So we are aware about those high current panels. So in some situation, we should be okay. So it depends which panels. Why am I saying this? Is what you mentioned is IMP. There's also ISC that we need to have a look, and that's how we go. That's how we see if it will work or not. So I will quickly maybe explain what I mean there, and that's usually a very good one to also check on the solar configurator. So the IMP on our inverter is how much we can harvest, or the maximum current, but we should, so 22 and 25 is how much current we can harvest. If you go above this current, it's okay. The only thing that you need to make sure is that you're within the ISC. So if your ISC, so let's say if you parallel 2 string, you bring it to 1 tracker, and if your ISC is more than the ISC of the inverter, ISC is short circuit current, is more than the inverter, then there will be some challenges. And that's what we need to have a look at as an example. So, but looking at the 13 amps, I think those ones should be fine. But again, I will need to check on the solar configurator. So if, for example, you have 2 strings which produce an IMP of 13 amps, 13 amps, of course, when you parallel, it gets added, it goes to 26 amps. On a Symo, shouldn't be an issue if the ISC is within, because when I said 13 plus 13, it was IMP value there. But it's a very good point. All right, good. There's another question. Why do you only go up to 6 kilowatt with single phase when you can make an 8.2 kilowatt Primo? That's I like I really like this one. So at this stage, that's in terms of what we made or manufactured, we are up to 6 kilowatt. We are also working on an 8 and 10. The reason is it's for bigger inverter. So for the single phase bigger inverter, it's a different chassis. So it will, from what I heard, the chassis of the 8 and 10 will be the same size as the Symo, if I'm not wrong there. So it's just a different hardware that we are working on. Testing is being already done, or is being, well, it's still going on those units at this stage, but we're planning to bring those bigger inverter. There's another question. Can you please provide data showing the MPP efficiency using 3 panels? I need to get back to you on this, Rick. So if we can get you to email this to our PV solution queue. So I'm just going to send that to all of you guys here. So this is our email address for all the application engineers if you have any question, but we'll follow up on this one. Good experience, I think, from Scott. So Scott mentioned that he's planning to install a Gen24 and BYD combination in their showroom so that customer can come and see, look at the app, look at the smart meter, and they felt that it was important to really understand and demonstrate the product. That's a very good idea, I think, Scott, so that the customer knows what they are seeing there. Another question Nick is asking is HVS is 2 minimum? Yes, it's minimum 2 if I'm not wrong there. I can double check this one, but it's usually 2. Can the battery charge from the grid? Yes, so we can definitely do charge from the grid, from another inverter. You can pulse charge the battery. Do the smart meter go before the switch? Yes, so I think question from Anthony. So if you have your switchboard, then smart meter, then the backup switch. I think that's what you mean. Yes, that's what you meant. So is the PV point 3-phase on the Symo or only single phase? PV point is always single phase. This one. Does the Gen24 have an integrated DC isolator like Snap Inverter series? The answer is yes. You don't need an external DC isolator with the inverter. There's another one. Can the Gen24 connect with a Google as well? So you're getting a Google Nest. There's a customer who did it. You will need to use kind of like another platform. It is possible, but it's just a bit trickier. It's not a direct option, but there is an option where you can talk to Google. You just need to do a bit of kind of DIY with the programming. But there is like a company who did it before. Do you have any more info on how the EV chargers? So I think you mean when we're getting the EV chargers. In terms of that, there will be a webinar. The best thing is if you register for our EDMs, so you will get all the news and marketing. The only thing is when you register for our newsletter, just make sure that when you receive an email or the confirmation email, just click that you receive it. Maybe sometimes it goes to your junk mail. We always like to check that they are not robots in a way, but yeah, something to check. Can we do multiple inverters like master and slave? Yes. Sorry, no, you can't do with the Gen24. That's why you have switched in if you need to do export control. So just in regards to this question, if you have multiple inverter and you don't have any export control and you don't have multiple batteries, then you can just install the inverter. You have, let's say, one battery and do all the monitoring. It will show the right thing on Solar.web. As soon as you have multiple inverters with batteries, then you need to have it switched in. John has a good one. Can I add PV in the simulator? At this stage, we can't. I think it's a good idea, good feedback for us to try to add this. Actually, that's a very, very good idea. Are there any plans to have a Gen24 Symo 12.5 or 15? At this stage, not really, but we should, I think, look into it if the demand is there for bigger one. Because if you, one thing actually that I didn't mention is those inverters, the Gen24, you can oversize by 150%. So on a 10 kilowatt, you can put 15 kilowatt worth of panels there. So you really want this inverter to clip as an example. So how long does the full backup option take to kick in? So we had this discussion. Usually we say between 60 to 90 seconds. It really depends on the voltage and also when the inverter is, how much DC is available. So usually we say between 60 and 90. Some customers say not even 40 seconds. So it really depends on the voltage there, but that's the range that we officially say. Alex had a question. It's great that your product is more sustainable, but what are you doing to get the product back at the end of life so it can be recycled and not end up in the landfill? So usually when a product has an issue, there's an with people. So it really depends. When we say the complete end of life, sometimes we can take the unit back here. It all really depends on the customer. So at the end of life, some people will say, okay, the product has an issue. They will say, I want another one back. I will just buy another one back. So what we can do is we can take the inverter back and then send another inverter out as a non-warranty product, as an example. So there's a few options available in terms of recycling, but that's something that we really focus on, because this heatsink, for example, can be reused from our side. But there's like few options. Is there a voltage limit or just amps on the Gen24? That's I definitely think it's a good question. So one thing which is different from our Primo Gen24 and our Primo Snap inverter, the Primo Gen24 goes up to 600 volts for single phase. So it is a single phase, so maximum is 600 volts. The Symo, it's 1000 volts, which is different. The simulator only seems to allow for one tower, not 2 or 3, that's right. So we usually do the calculation for only one big tower or multiple different sizes. It's something that we can give a bit of a feedback there. All right. Looks like the other questions are pretty similar here. Quite a lot of questions. So I've sent, I think, all of you guys the email if you want to get in touch with the application engineering team. So if you have any other question, if you missed your question, we'll try to answer all of them also. But if we miss it, we have the PV solution queue. Also, we'll be at Smart Energy next week. So please come and say hi to the team. The last part that we have on our side is all of you guys who came to our previous webinars for this webinar series. All right, I think that's pretty much it for today. Thanks again, everyone, for joining the webinar. I know it went a bit over time. We said actually 45 minutes for all those webinars, but it has been a great session, and I hope to see all of you guys soon. Thank you very much, and see you all guys soon.